Hello, my name is Michał.
And I'm Jens, and we present you here the paper Schopenhauer Diagrams for Conceptual Analysis, in which we introduce the main principles of the philosophy of language of the German philosopher Arthur Schopenhauer and his diagrammatic method and interpret them with modern means. In the 1820s, Schopenhauer produced a manuscript on logic, which contains numerous logic diagrams on more than 150 pages, which were applied in a novel way to very different areas, including the philosophy of language.
These diagrams always have the form of circles of different size, which are meant to represent concepts in their relation to one another. Schopenhauer applied them for explaining issues from numerous fields, including logic, semantics, or argumentation, and we believe that his method of visualizing thoughts can be useful in modern contexts too. Our paper is basically divided into two parts, which we split into shorter paragraphs for the convenience of the reader. In the first part, we focus on presenting the most crucial elements of Schopenhauer's philosophy of language. These include such issues as his understanding of what concepts are, how they are made, and how they relate to reality. Then we focus more specifically on his considerations pertaining to the relation of language and thought, the definition of logic, or the problem of meaning. By doing so, we provide context for better understanding of what he represents with his diagrams, which are discussed in the second part of the paper.
Since Schopenhauer does not give any rule on how to use his logic diagrams in the philosophy of language, we first reconstruct one of his diagrams with three terms and then try to distinguish clearly between syntax and semantics. We notice that not only the circles, but also the regions have a certain meaning. With these Schopenhauer diagrams, various theories of philosophy of language presented in the first section of our paper can now be presented concretely and visually and measured on the basis of geometric form. For example, the bundle theory or the degree of abstraction of terms. In the final step, we then extend the reconstructed diagrams with two more terms, in which the circles intersect some spheres but not others. Thus we have approached more complex Schopenhauer diagrams in this paper. Thank you very much for your attention.